Okay, so continuity at a point. The definition is a function f is continuous at c when the following conditions are met. And c is any real number, doesn't matter. F of c is defined. So basically, you have to be able to plug it in. Number two, the limit exists at c. And number three, the limit and the functional value have to be the same. So basically that means if I plug in C, I get some number. And if I find the limit, I get some number. Those numbers need to be the same. Okay. Also a note, this is the notation for left-handed limit coming from the negative side. And this is the notation for positive coming from the right. As x approaches. All right. No, wait a minute. I'll wait a couple minutes. Any questions on this notation? Today. Okay. You guys cool on this page? I'm gonna switch over to the homework. If you need a couple minutes, it doesn't matter. Okay. Assuming you're good then. All righty. Can y'all see the homework? Okay. So notice, look at number one. You see, it has the plus sign. You can still see it, right? I moved the screen. Let's see. Where is it? Okay, here we go. So again, just refresh ourselves. Coming from the right side, C is 6. Here's 6. So what are the y values doing as we approach from the right side?
Approaching 3.
Yeah, it's approaching 3. So you would just say simply, so the right-handed limit is going to 3. So you would just say 3. And what about the left-handed?
Same thing.
Same thing, right? Okay, now since they are the same, going the same place, then you would say the limit exists and it's also 3. So that's what I meant by this notation over here. Hopefully this thing doesn't crash on me. Here. If these two are equal, then you say the normal limit exists. They have to be the same. You can have individual limits, but not the actual limit. Okay. Now, if any of these three are not true, then you would say not continuous. So if any of these fail, not continuous, all three have to be true. So back to the homework. Excuse me. So the question becomes, are we continuous at 6? Does it meet all three conditions? Because on the exam, you have to explain, right? Why is it continuous? Is it yes or no? So looking at your notes, is number 1 true?
Yes.
Yeah, right. You have a point there at 6, 3. Okay. And we said the limit exists, correct? Number 2. And number 3, is a functional value the same as the limit? Right? Do you agree that f of c, so I try to write with the mouse here. Doesn't look much, almost looks as bad as my normal writing. F of 6. Right. This is going to be equal to 3, correct? So this is the same as this. Therefore, number 3 is good. So once those three, you check off all three, then you say, yeah, it's continuous because of this. Is that clear how you would explain yourself? Or how you show it's continuous?
Yes.
Let me know. If I make no sense at any point, just tell me. Not a big deal.
I might have a question about it when we get to uh stuff with denominators. But until then I'll wait.
Okay. Yeah, that's no problem. Alrighty. So here, um, remember the answers don't matter. The understanding matters, right? The limit from the right, we're going this way. What number are we approaching from the plus side? From the left side, we're approaching the same thing, right? So therefore, they should both be the same. If both are the same, then the limit exists, which is going to be 2. We've talked about this already, but now they're having us do the one-sided as well. Okay. Now, out of those 3 conditions on the notes, which one does it violate?
Numbers. C.
Which one?
C.
Yeah, let me show you. 1, 2, or 3?
I would say 3.
3, right? Because the limit exists. You can plug it in and it exists, but the functional value is not equal to the limit. What is the functional value at C? What is f of C?
3.
Yeah. F of C. In other words, f of -2 is 3, right? It's right here. And the limit is 2. So
Can you explain why that happened?
sure, yeah. So the way to define this function, right? They're basically saying we have one function, but this is a piecewise function. We have either 2 or 3 functions glued together. So they're saying, you know what, there's a hole here. So basically you have a function defined this way. So they're saying you have 3 whenever x is equal to -2. But over here you have some sort of absolute value function. Probably +2. This is a guess, estimate, I guess. Do you remember these piecewise functions? So basically it's saying you have this absolute value function, this v function, anywhere except -2, but once you get to that hole, they define it as some random point. So I could have put the point over here, or sorry, up here somewhere. Who cares? Not over there. Up here. Right? It just depends on how it's defined, and they define it this way. That's all it was. So that means, though, the limit is one number, and the functional value is up here. So this number is the limit that we showed, right? Then you plug it in, you get this one. So since they're not the same, this one's 3 and the other one's 2, it messes up condition 3. So not continuous.
So
That makes
if it
sense.
wasn't a piecewise and that x and that 3x equals -2 wasn't there, then it would be a continuous function, correct?
Yeah, if it was just filled in and there was no floating dot,
Yeah.
yeah, for sure, it would be. You can have piecewise that are continuous, but it just depends what C we're talking about, because it's technically continuous at all these points, right? And over here. But this specific point, it's not. And any other questions? Okay. Check this guy out. Kind of like a step function. Is it defined? Yeah, it's defined at 1. Okay. But what do you notice?
It's disconnected.
Yeah, it is disconnected. It's 2 lines. The C in question is did they label it? Oh, there it is. Right there. C is equal to 1. So from the right side, the positive side, what is my limit?
-4.
Yeah, it doesn't really change, right? It's always at -4. So cool. And from the left, +4. They are not the same. So what does that mean?
It's not continuous.
Yeah, for sure not continuous. That's true because it violates rule number 2, right? Condition 2. So if there's no limit, then right away, not continuous. But also, because they're different, then you'd say the limit does not exist. D and E. Is that clear?
Wait, I'm sorry. Why does the limit not exist? Like, why?
So here in the notes, we said, let me show you. We said the limit, in order for the limit to exist, right?
Yeah.
It only happens if the left-hand limit is the same as the right-hand limit. If they are the same, then you say it exists, but they're different, right?
Mhm.
So since they're different, does not exist, which violates number 2 because it doesn't exist. So not continuous. It's not going to be continuous.
Oh,
Oops.
can I take a screenshot of that of those notes?
Yeah, sure.
Let me see. Okay, thank you.
Mhm. Okay. Any other questions on 3? Okay, cool. All right, for number 4, we don't have a graph. It doesn't ask about continuity, and it only asks from the left-handed side, right? So you have multiple techniques to solve the limit, but since it's just one side, I recommend just graphing it. But you could also put numbers closer and closer to 0, or sorry, to -3, and see what the table's doing on the left side. And that would be your limit. But graphing will be, I think, the most clear way. Let's see what's going on. Okay. They said -3, right? So -3 is right there. What's the graph doing from the left side?
It's infinite.
Yeah, it looks like it never actually gets to any value. Do you remember in college algebra when we had those asymptotes? Anything that causes division by 0 is going to create one. So you can visually see that if I were to plug in numbers closer and closer to -3 from the left side, that they get super huge quickly. So as that happens, it would be infinite. So technically the limit should be -infinity. But for this section, you just put does not exist. So if it shoots off to infinity or shoots downward, or your calculator gives you giant numbers as you plug them in, you would say does not exist. Any questions on 4? Okay. So here they just want you to discuss the continuity of the function. All right, well, it's continuous everywhere except at -1 because there's a hole, right? If you were to graph it, you'd get this. But the limits from the left and right are the same. Approaching -2. So the limit exists, but we can't plug it in. So number one is not really defined on your conditions. So I would just say, yeah, it's discontinuous at -1. Pretty much all you can say. At -1, condition 1 is violated. Not continuous there. Okay. Now, if you were to factor, like, see how this one could have been factored, right? And it cancels something, then that would be an example of a removable discontinuity. If nothing cancels, you would say non-removable. Excuse me.
Could we do the difference of squares there?
Yeah, that's why it's removable. Let me write it on the paper. I believe it was +1 on the bottom, right?
Yeah.
So the top is a difference of squares using your formula. So you should see that these cancel because they're products. So notice how I removed the discontinuity part. It's no longer an issue, but technically it's still undefined there. It's still discontinuous, but when it cancels like this, you can consider it a removable type. So if it doesn't cancel, I'd say it's non-removable, like this guy. Nothing happens, it's just a, what's it called? Asymptote at 0. All right. I'll leave the rest to you. Do you have any questions on continuity at a point and left and right-handed limits? Does it make sense? Okay. Excuse me.
I have a question.
Yeah, what's up?
So is a removable limit a continuous function?
No, it's still not continuous at that point, but it's removable. I would think of it as composite functions. Like even though the result looks fine, originally it wasn't fine. Okay. So here they're basically just calling those infinite numbers that we are talking about earlier, or those limits. They're just go ahead. They're just telling you, you know what? Go ahead and put infinity. And as you look at the graph, as we approach 2 and -2, you're gonna get infinity. They both shoot up. So infinite limits. Here we have a left-hand limit shooting downward and a right hand shooting up. So left would be negative infinity, right would be infinity. Does that make sense?
How do we write infinity?
I should have a box.
Oh, the box on the screen.
Yeah, it should pop up something. If not, I think you can just type infinity.
No, you always see something on your left. That's where you get the character that you need. On your right.
Yeah, this little negative symbol means we're going from the left. This plus means from the right. -2 was this point here. Oops. Was there any questions on number 2? Or you see how it's very conceptual, right? We're not really solving problems right now. This is more of a do you understand? The definition and the visual. So here they didn't give us a graph. So you can either A, graph for yourself, use a graphing calculator or graphing website, or plug in numbers closer and closer to the number 2 and just see what happens. So if I was plugging in numbers from the left, you should see like 1.9, 1.99 just gets humongous. I go from the right, 2.01, 2.001 gets really large too, but one goes to the negative, one goes to the positive. That'd be one way to approach it. The other way is to graph. What's it again? 1? Yeah. So as we approach 2 from the left side, shoots downward quickly, negative infinity. On the right side, it shoots upward quickly, positive infinity. Okay. Does this concept make sense? Right, so it's the
Yeah.
same thing over and over again. So let me know if something's weird or you see how it's kind of repeating itself from the beginning of this chapter 2. All right. So here's what I was saying earlier. Here they're making you plug it in instead of using a graph. As I get closer and closer to the number -2 from the left side, what number is it going to? From the right side, what is it going to? You can see how big they get really quickly, right? This is an indication that it's infinite. If you're not convinced, put a bunch of zeros and then a 1, and you'll see. Or a bunch of 9s, like this side. You'll see it kind of blow up pretty quick. Or you can use your trace function, whatever. I don't care. As long as it makes sense. Yeah, they just want you to choose the correct graph. Whatever. It's not a big deal. Okay. Number 8, 9, and 10. They're talking about asymptotes. Do you remember how to find vertical asymptotes from college algebra? Oh, you just set the denominator to 0, and that's it. Solve for t or whatever if you can. And that's it. Now, can this denominator ever be 0? Is there any real?
No.
No, right? You can't square something and magically get a -9 that would cancel the 9, right? It's not going to happen. It will never be 0 for any real number t. So since it can't be 0, there's no vertical asymptotes. Over here, it is pretty clear what makes the bottom 0, right? Excuse me. So this is an equation of a line. It's not the value 2, it's the vertical line x equal to 2. So this is a vertical asymptote because the value 2 makes the bottom 0. So this one, you could just set x minus 2 equal to 0, solve, and you would get this. Over here, you can't solve it. So it doesn't exist. Number 9, though, if you have any logarithm, so if you have any log that makes the inside 0, then that would be a vertical asymptote. So those are the two types. A number that makes the log 0, and anything that makes the denominator 0. Well, those are your asymptote equations. Is that clear or no? You want to see more steps on this one? Or what I'm saying makes sense?
Can I see a step? I kind of want to try to see what you mean.
Yeah. Okay. I forgot what number it was. Let me fix that just a second. All right. I'm gonna use X just because my T's look crappy. Okay, well maybe everything else does. So the steps to find the vertical asymptote. So to find one, set the denominator equal to 0 and solve. Denominator is right here. Do you see how there's no solution?
So it's no solution?
Yeah, this can't be solved, right?
Yeah.
Because you would have to square root both sides, and this is a -9.
Mhm.
So number 10, so you would say just does not exist. There is no vertical asymptote.
Huh.
Number 10 has one, so let's show this one. This one crap on the top here. Set the bottom to 0. Solve for x. Right, there it is. Vertical asymptote is x equal to 2. That's what we did back in college algebra. Yeah, remember?
Yeah, I do. I just need a little bit to kind of see it. That's why it's like it slowly comes back. You know what I mean? But
No, yeah, don't be afraid to ask. That's why we're here. Just let me know. Okay. So any questions on when you have an infinite limit, left or right, positive or negative, how to find it with a graph, how to find it by plugging in numbers, and how to find vertical asymptotes. Are those things clear?
so finding the limit, I think I need a little bit clarity of that. I mean, it might be my fault. I'm sorry, because I got off late of work and I joined like 40 minutes late. But like finding the limit, like what is the general rule for that? So I can kind of remember, like, oh, okay, this is this or this and this. I don't know.
Well, okay, let's just go through this one example here. Can you see the graph?
Yes, sir.
So let's say I pick this random point here,
Okay.
and I said that my C is 0. Right? I'm saying limit. The question is something like this: the limit of f as x approaches 0. So you would go to the 0, which is right here, right? And see what is happening on the left side, what's happening on the right side, and what y value, sorry, are they approaching? If they are the same, then the limit exists. If it's different, then you'd say it does not exist. Unless they ask for just the left or just the right, then you give them the left or right. So it just depends.
Or when we have like for this graph, for example, where the limit would be negative and positive infinity from the left or right. That only works.
That would be here though, right? At 2.
I wasn't referring to your demonstration there. I was referring to the
Oh, I'm sorry. Which one are you talking about?
Oh, just this graph that you've plotted here. As so if the limit would be negative infinity from the left and positive infinity from the right. Right.
Oh, you're talking about the graph on the right now, right here, right?
Yeah.
Okay, yeah. So yes,
Two.
you're right. Only if we're talking about C being 2.
Right. So C is
And if we had a 2, you would say it does not exist, right?
right. Unless it said x to 2 negative or x to 2 positive. Right.
Right. Because the left would be negative infinity and the right would be positive.
Gotcha.
See if I can copy that and paste it.
I thought okay, I'm sorry. I have a little question. What do you mean, like if a limit does not exist per se? Like, is it proven wrong or?
So the definition, in order for it to exist, the left and right limits must be the same.
So like the example you showed, they're not the same. They're uneven.
On this right here, the on 0, they are the same because they're both going to -half.
So
Let's look at another example.
yeah, maybe I can see an example of what's not the same.
Sure. Okay. Yeah, I think you missed 2.4 part. I think that's why.
Yeah, I'm sorry about that.
Here, this is the one where they're not the same. So from the right side, you see how as I approach C, which is equal to 1, that's -4.
Yes.
And from the left, it's 4.
So because one is negative and one is positive, it's considered not the same. So they have to be the same number, same negative or positive.
Yeah, so see how this says plus right there?
Yes.
That means from the right side. So as we come from the right, approaching number C, which is 1, what are the Y values doing? Well, they're going closer and closer to -4. Therefore, you put the right hand from -4. The left hand, the Y values are going to 4. Since they are different, the left and right, you would say does not exist.
Oh, okay. Oh, okay. I do kind of see what you mean now. All right.
Let's see, there's another one here. See how here, it's real quick. Here, the point in question is 2. So as we get closer to 2, you're trying to look at the Y's. What are the Y values doing? So if I'm approaching this guy, the Y's are going to closer and closer to 2, right? See what I mean?
Yeah, I see what you mean. Like they're not. So is this one the same then, or is this one different?
Yeah, they're both going to the same place, which is +2. So as the limit approaches -2 from the left and -2 from the right, the Y's are going to 2, therefore the limit exists
Oh, because they're meeting each other, right?
because they're the same.
Oh, okay, okay.
They have to be the same. The right, the positive one, the
Uh-huh.
left, the negative.
Yeah.
If these are equal, then we say the limit exists.
Oh, okay. That kind of makes more sense now. Thank you for
Yeah,
the.
no worries. Okay. I don't think I'm missing any section, am I? Okay. All right, so I've posted the review and I've posted the exam. So yeah, you can do it anytime from today till the 24th. I'm sorry, the 23rd. So what I recommend is make sure you start a few hours. If you're going to wait till the last day, make sure you wait. The latest you do is like 9 p.m. or something. Because if you start at 11:30, it'll close at midnight no matter what. Doesn't matter. You didn't use up your whole time. The due date is midnight, 23rd. Okay. And it'll be 2-1 through 2 or 2-2 through 2-5. Then I'll send you the videos, sorry, the reviews right here. I recommend doing that a few times. Solutions are in here. It shows like how I want you to set it up or write it out. And I'll also send you a video for the review. That way, maybe Wednesday you can just focus on catching up on homework and preparing for the exam. Okay. You guys have any questions from any of the sections? You guys doing okay?
When do you have your tutoring? I might need the tutoring on a 2.4.
Usually in the morning, so just let me know like maybe 24 hours before, and I'll get on like around, I think it's around 10. I think I'm gonna check. I forgot actually. It's 10 or 9. Yeah, if you want to go to Math World, they're open through Zoom or in person. They're really good. But you can come see me, just give me a heads up. I'm usually home pretty much every morning. Before 11 would be best. So like 10 to 11 or 9 to 10 is fine. Just tell me. Monday
Okay.
through Thursday.
Send you out
if-
there tomorrow.
I'm sorry?
Oh, sorry. I said I'll probably send you a reminder either today or tomorrow.
Yeah, just let me know. Also, I'll try to leave time after class too. So if you have any questions or you want to work on stuff, we can. Or if you're stuck on something, it's not a big deal.
Okay.
Let me take roll, and then if y'all have questions, let me know. No. Oh, there it is. Oh, is Dana Ventura here? No. Okay. Leandro Burgos,
Here.
Evelyn Calzada,
I'm here.
Adam Dobbins,
Here.
Astrid,
I'm here.
Simon Metz,
Here.
Kesamar,
Here.
Brianne Bettis,
Here.
Serena Rayburn, okay, not here. Vivian Villa.
Here.
All right. Anyone that I missed? All right, guys. If you have no questions, you can feel free to go to bed or whatever. If you do, feel free to stick around. Let me know.
Bye. Have a good day.
You too.
Thank you.